And now we are reaching the last speaker. So it's Jack again. So Jack, if you're online, you might want to turn your video on. Okay, good. I guess I can skip the intro and you can go ahead. Thanks. So okay. This time is about COVID.
So let me. Okay, so this time is about COVID. I would say COVID has been the hottest topic for the industry for the whole year. I would say. So our SS ERM committee is working on some projects to understand COVID data. So previously we had a plan that we try to get some MOH data and share some highlights from there, but this is going to take some time. So today I'm mostly focusing on the data monitoring. So this is ready to figure out how can we monitor all this data more actively. And if another pandemic hits Singapore, then we are better prepared. And if the COVID situation changes in the future, we are also better prepared. So then the thing is really,
Jack, you are not on presentation. If you want to keep it like that, you might want to reduce the left window.
Okay.
You're not, yeah.
Okay. So yeah. So I would say, I think a lot of people ask the question of, is COVID a black swan? And the black swan is very often used in the last few years. So of course, to the normal people, COVID is definitely a black swan, where nobody expect that, we have such bad pandemic and people cannot travel, have to wear masks all day. But to the actuaries, right? Actuaries shouldn't think in the same way as the most people, right? So in the actuaries, we are very used to this idea of 1 in 200 events. So then the question is really, is COVID in such a case that is like a 1 in 200 that we actuaries haven't expected before? Then there's a very interesting report from RGA. So it's understand the word like this. So for a black swan, we have to understand the impact. So the impact has been huge. And COVID, it is big. It has been outlier. So the outlier from an insurers, from an actuary's point of view, is it should happen less likely than a 1 in 200 events. And it has to be unpredictable. But for COVID, right, it seems now, as of now, it seems that the impact of COVID, at least for death rate, is much lower than the 1918 flu outbreak. And also, so this only happened about 100 years ago. So COVID shouldn't be a 1 in 20 events, because 100 years ago, something much worse really happened. And in the last 10 to 20 years, we see a lot of pandemic like SARS, MERS, H1N1, and all these pandemics are much smaller in scales, but also very similar in nature as COVID. So to actuaries, our problem is for such an event, right? For such a pandemic that is probably within 1 in 200. For us, it's not a problem of if COVID will happen. So we know it will happen because, SARS happened, MERS happened, H1N1 happened, and the 1918 flu happened. So it's not a question of if those will happen. It will definitely happen in 1 in 200 years. But the question for us is, when such a pandemic hit us, what's our solution? So then, on the prediction side, right, we need to increase the accuracy of our input data. And we need to validate the probability distribution of our assumptions. And most importantly, all these events are tail risks. So we need a very good model to model all these tail risks. And also for our response to all these questions is that previously in most insurance companies and market, the market standard is we get some public data from the government probably every few years. or maybe every year, depends on what kind of data we are looking for. But nowadays, there are a lot of public data available online. Just now, Kate shared something that the LT in Singapore is publishing the traffic data every day. And these data, I think most insurance companies are not really making use of this data. But if you make use of all these public data, then the data can publish, and then you can update your model, update your reports every day based on the most recent data. But then after that, it introduces another question that if you update the data every day, you need to make sure you need a very consistent reporting format for data you have. Okay, so I mean, for COVID, I mean, I think MOH has been doing a very good job. I would say Singapore government is I would say very outstanding among all the countries. So we have, I mean, we following the MOH WhatsApp group. They publish all this data every day. So they show number of imported case, active case, discharge case, and cases in the communities, hospitals, and so on. So MOH is making an effort to publish data every day, and this data is public. So I mean, and all the other governments around the world, they're also doing the same thing. So everyone is publishing this data every day. So then this data is also available. So to our insurance companies, is that the question is, how can we build a very good system to collect all this data, put in a single place for us to analyze the pattern? So I would say the earliest movement is really done by, the earliest movement done, I know is done by the Johns Hopkins University. So this is probably the best medical school and hospital in the world. So they developed this this website in the very early days. So it started by probably a few professors and students there to collect all this data manually from various sources. Then they started to build API connections to collect the data, and also visualizations to visualize the data. So the Johns Hopkins University has been maintaining and building this dashboard to show how many cases worldwide, number of cases, number of deaths, and they added some reports, analysis to show all this data. And this is for free. So a lot of academic research is actually using their data. So then, I mean, this data extracted from yesterday. So you will see India is in a pretty bad shape, and the cases in Indonesia and Philippines are growing, and Japan is also growing. So if you go to this website every day, you will see the most recent data across the world. And also there was some good visualization of the data. And also WHO is also building something quite similar in a slightly different format, but it's also showing the same thing. So the number of cases, number of deaths, and also there's a visualization tool to show the number of cases per country. So the size of a bubble represents how many cases in that country. So see all the governments, the international agencies, and private agencies are building these dashboards. So I mean, for their own, I would say for their own people, for their own country, and for the academy and the commercial companies to help everybody to develop products, develop solutions, and better cope with the COVID situation. So then the thing is, suppose but the question is, for all these dashboards, right? These dashboards are not really built for insurance. At least it doesn't tell you, I mean, how much premium you charge and how much claim is expected. So all these dashboards are not built for insurance companies. So for insurance companies, right, if you want to monitor all this data automatically, so we probably want to build our own dashboard and add our custom metrics onto all these dashboards. So then the question is, if we want to do it, how can we do it? I'll say the first question people ask is, like the previous presentation is, I mean, what kind of programming language do you want to use? Should I use, I mean, can I use Excel VBA? Can I use R? Can I use Python? Or can I use other language? So the advantage is that nowadays, building all these dashboards doesn't require any programming. So more or less you can, I mean, you have the data somewhere, more or less you can just click a mouse. You don't have to touch a keyboard to build such dashboards. And there are a few very good solutions available. I would say Tableau is, I mean, Kate has introduced Tableau. I mean, I think it's a commercial solution to pay for it, but it's very specialized in building dashboards. And also, I know there's also one more solution by Google. So it's mostly free, I would say. So it's mostly free if you don't use in a very large scale. So of course, there are other platforms available for you to build dashboards, but my personal experience is that these two are more convenient and also more well established. Okay, so let's take a look at the Tableau dashboard. So Tableau dashboard, so Tableau, right, you can link your own data. You can build a dashboard like this. So all these, I mean, this kind of dashboard doesn't really require any programming for you to build. So you can type your own keywords. You can choose your own job bottom box. You can show multiple data in the same chart. And you can choose different chart types. I mean, for example, I mean, you have the first one is a line chart. Then down there is kind of a bar chart. And there are a lot of these choices that you can make. There are a lot of choices you can do for all these different dashboards. So all these, but doesn't matter if it's MOH data, if it's John Hopkins data, if it's WHO data. So if you have the data somewhere and you can extract the data in real time, then you can more or less build all these dashboards by yourself by click and drag and choose your format, choose your data source, and also tweak a little bit on what kind of data frame you want to show to build all this data on Tableau. But then you also have, there is also another solution. So I'm going to focus more on, because in Igloo, we work more on Google because it's a more online solution, I would say. So Google's Data Studio also allow you to build all these dashboards. Doesn't require you to know any programming language. Of course, if you know programming language, you can build better dashboards. But essentially, you don't really need much programming language to build all these dashboards. So here are some examples that I've built to show you what they do. So the first one is some machine learning. So it's a table chart. The second one is Search Console. So then you can see a pie. You can see a pie chart there. You can see some line charts. You can build like multiple segments in a single dashboard. The third one, you can see some view bars. Probably you can compare male and female as for our insurance industry. So in the middle, you will see some bubbles, some charts, some combination of bar chart and line chart and everything. So all these dashboards you can actually build without much coding, without the code behind. But then the question is, you still need to get the data. So for Tableau, you need to somehow upload the data to Tableau. So then you need to probably need some engineers or IT guy to help you with that. But for Google, it's kind of, you have the data in the Google system, then it's very well integrated. So they can directly fetch data from there. And Google will take care of the rest. Okay, so then I'll say for actuaries, most of the time we do some analysis, we take some data, do some analysis. Usually the conclusion is that there is not enough data. But of course, to me, there is always not enough data to reach a firm conclusion. But usually there is enough data for you to make some estimates. But of course, but then the problem we're facing now is really government publish data every year or every few years. Our head office publish their new assumptions every year. And most likely, we don't really have the API system to get data from external sources. So then we end up with the problem of not having enough data. But actually, there were a lot of public data available, and they are I would say they're not really free, but they're more or less free. And you can use all this data to improve your product. For example, we have this Google is launching something called public data sets. So they host this data online that everyone with a Google account can get this data. And these data are very high value, high demand public data sets. For example, there's a lot of environmental data that you are probably interested in. So a lot of environment data, the US government publish a lot of environmental data online, mostly in US, but also there are also a lot of weather data worldwide from thousands of weather stations around the world they can get. So it includes temperature, sea levels, and everything. And also you have some NASA data on satellite image that is also published online. Then you have some GitHub Bitcoin if you are more into tech, then you can use all this data. And all this data are published on Google. Doesn't mean it's free. So some of database, some of data are quite big, so you have to pay for it. But still it's more convenient than trying to track data yourself. So to address the question of COVID-19, so Google has started an initiative that for the COVID-19 data, they will provide you for free. So you don't have to pay for it. So the data is there. You want to do any analysis on the data, do any query, SQL, extract features, and do a summary of all these data. It's free. And all this data includes data from New York Times, Europe, Google, Street Map, and global health data from World Bank. So then all these data, actually you don't have to pay for it. So it's free for you. So you can build all these dashboards by analyzing the massive amount of data behind all these dashboards. But of course, I mean, all these dashboards are theoretically for education research purpose. So you want to commercialize a product, you need to talk to your internal compliance people to figure out, does it require you to acquire a special license from Google? So then here are some data sets that are available, that is freely available for us to use. For example, you have the COVID-19 case by country. So of course that includes Singapore and all the Southeast Asia countries. So you don't have to go onto the MOH or WHO website every day. So you can build some, there are some ways that you can get this data, fetch that from the public data source to your own database every day. Also, then there is Johns Hopkins data that should be the same as COVID-19 data. I mean, depends on when they are collected. And also there is a very interesting mobility impact data. Okay, so this mobility impact data tells you how much mobility, how much the people's movement or people's daily activity has been impacted. It will tell you like how many cars, I mean, how many percent of cars are, and the percent of cars on the road, and how much the percent of growth and reduce in grocery consumptions, or reduce increase in park visits. And all this data they can get from this COVID-19 impact data set. So for example, you will see that during the COVID-19 period, there were significantly less cars on the road. So probably your motor insurance claim rate has decreased significantly. And all these you can cross-check with this data to see how many cars are there on the road now and every day since beginning of this year. And you can use that data to compare with your loss ratio for motor insurance. So then you have some COVID-19 search symptoms data that I'll cover later. But also there was some external data that is not really directly linked to COVID. So for example, you have some GDP data. So maybe you have assumption that poorer countries have a higher infection rate. Yes or no, you can cross-check with that. You can cross-check with the GDP. And there was some government response tracker, and it tracks every single response from the governments worldwide. So then you will know so if some country has announced something before, so then you will estimate what's the impact on my country or in Singapore. So for example, if Singapore want to launch travel bubble with some other countries, probably some other countries have done it before. For example, UK probably have done it before. So then we can estimate what's the likely impact if Singapore launch a travel bubble with some neighboring countries. Of course, then there is weather data from COVID, so you can try to figure out, does temperature really impact the incidence rate or death rate? And of course, there are multiple ways we use this data. So here is just one way. So probably just start with the COVID-19 instance and death data from the Johns Hopkins University, or you can use the WHO data anyway. So if you combine that with the mobility impact data, right? So then you will see during this period, there are less cars on the street and less business are open. So then you can use this data to price your business interruption and your motor insurance. So this data will give some hints on what's the likely loss ratio, claim rate, and what's the recommended premium rate in the future for these two products. And in the middle, I mean, if you combine that with the government response tracker data, then you can try to understand what's the impact of the government's responses and government policies. For example, if travel bubble, I mean, fifth phase three is announced with some more relaxed terms, and if travel bubble, Singapore start a new travel bubble with some other neighboring countries, and what's the likely impact? Because some other countries has done this before, and of course it's different situation, but some countries done similar things before, and you will know what's the impact of their policies at that time. So then it's a better educated guess on what's the likely impact on Singapore. So then of course you can combine the cases data with the weather data to see what's the seasonality of this COVID. Okay, so I mean, so yeah, so last time, so in the last slides, I didn't go through the symptom search data. So this may be interesting for those who look into health insurance. So basically, this is 3 years of data of Google search, Google keyword search on a lot of the symptoms. So I mean, the 3 respites are like three flu seasons of the last 3 years. So you'll see that, I mean, if you go to the first column below, down there, you'll see in the last year, there were a lot of search on fever compared to the last 2 years. And there was also a significant more search on cough and common colds than the last 2 years. So then you will see, I mean, of course, this is a combination of that some people are infected, and also other people are more anxious when they have a cold and they may suspect it's a COVID, but it doesn't have to be. And there's some other very interesting analysis is that if you look at the bottom right corner, a lot more people are searching hair loss. So, I mean, I don't really know why. So probably people stay at home and more worried about things and eat out less healthy, don't exercise more. So then there was more hair loss than the last 2 years. So if you use all this data, then you can get better customer feedback. So you will kind of know what's the current concerns of my customers, and how can I develop products to cover new conditions. Okay, so then the question is, so then I've explained where the data are and what data is available. So then I'm going to go through the process of how do we develop such a dashboard. Okay, so the development steps is mostly 4 steps, I would say. The first one is to locate the data. I mean, do you find the data online somewhere that is accessed from the cloud? Or, I mean, you can download data to your local disk, or you can download data and upload somewhere. So you need to locate the data, figure out what data you have. And then you need to link the data. So because ultimately you want to show the data only on your own desktop. You want to share the data with the whole public that everyone can view. Or it's also possible that you only want to share the data with your own team or within your own company. So you want to develop products, you want to develop a product with someone with your own company. So you need to link the data somewhere and figure out how to show the data. And then you need to choose the fields because all these data are not tailored for insurance. There are a lot of data in there. And some fields are useful, some are not, and some you need to link a few data sources together to figure out what's already going on there. So you need to choose your fields. So then ultimately you need to improve the visual. So I mean, if it's internal, then it's less of a concern. If you share with external people, you need to make sure your dashboards, your numbers at least look pretty and look professional. So then you repeat the above steps to improve your presentation and ML data into the report. So the thing is, if you really want to do this, there's no coding required to build some dashboards. Of course, if you know coding, then I mean, the more coding you know, the less case you want to do. Then the more coding you do, the better dashboard you can build. Okay, so the first step is really to locate the data. So for example, if you use one of the data sources I mentioned previously, you will see something like this. For example, you will see by each day, the number of cases, deaths for each country and territory there are. So after you locate this data and figure out that this is the data I'm going to use, you need to link the data. So somehow you need to upload the data to your cloud, or link the data somewhere, or find a source and upload data there. So I mean, but if you use Google, then Google's internal system is kind of convenient, that you only need to choose your data source inside the Google system. So you click a few times, select this table in the Google system, then the data is there. Then linking is done. Otherwise, you need to upload the data somewhere, and it's probably less convenient. It will be probably less convenient if you use Tableau. So then, the data is there. So then you need to make a choice of what kind of data I want to show, and how do I want to show it. For example, this Google interface asks you to do a few things. On the top right corner, it asks you to choose a chart type. So number cases, then you more or less you want to use a line chart. So then down below, you need to choose what kind of data range you want to show, and what kind of measure I want to show, and how I want to break down my data. So in this example, I want to break down my data by country. So that's the in the middle, the breakdown of geo ID. And then the metric I want to show daily number of confirmed cases. And then you will get this kind of chart. So this is a very basic chart, doesn't look so good. So you can improve on the visual later, but the data is there. So you finish your field of choosing a field. So then it's really spend more effort to improve the visual, choose the right metric, and improve the visual, choose the right color, right metric, and make sure you get the right amount of data. So then you can, if you spend some time, then you can build a dashboard like this. I mean, I spent some time, it doesn't really spend too much time, so I built my dashboard like this. So to build all this dashboard, there are a lot of features you can use from Google Clouds. That is, you can have a data range selector, so you can select the number of cases within a more specific data range. You can also have a field selector. For example, I can only select which country I want to see. And there is a peer-to-peer comparison. So up there, we'll see number of cases. Well, it's 14 million. So that is 56% more from the last period. So the little arrow and the green numbers are calculated automatically. So you don't have to calculate yourself. And then there are charts and maps. So number of cases, you want to show a line chart, or number by split by country, you want to show a pie chart. And you can also visualize a country map. So it's kind of very convenient. And also if you want to do some coloring, it's also automatic. And the best thing is this kind of dashboard, you can embed to a website. So if you have a company website, or you want to design your own website through Wix or some other tools, you can embed this dashboard to your own website, so other people can view it as well. So then you can control access by email address, OTP, or just give it a public access that everybody who you intend to share the data with will have access to the data. and Google and all these cloud providers will do their work to make sure the dashboard is stable and also is automatically updated every day. Okay, then since we have some time, let's check a few sample data. I mean, what kind of data is available there? So for example, in global data, you have the day, month, number of cases, and death, and GOID, and the population. So all these are very, very standard data they want to do. That's the first data you want to do. You want to check for COVID. And the mobility data is kind of interesting. So every day for every country, it will tell you what's the retail and recreation percentage from the baseline. So for example, this is Singapore. This is Singapore data I extracted from Google. So you see that all the numbers dropped significantly on April 6th, on April 7th. And that's the exact date where the government announced the circuit breaker. So after the government announced the circuit breaker, you will see that all these indexes of mobility reduced significantly. So the public data source will tell you people are not coming out. From the day since the day the government announced this circuit breaker. So then maybe you have some business interruption coverage. Then you will have some estimates on what's my claim rate is going to be, and you have some motor insurance because people are not driving as much. Then we have some estimate what is my motor insurance claim rate going to be. Okay, then here is also some data on the government response. So this is Singapore, for example. So we're more familiar with. So then this data source give you all the responses from the government. So like government's announcing something at least every month. So this is sample for gathering nodes and also some other data. So if you have some algorithm to extract some keywords from all these data, from all these government responses, then you will have you'll figure out some patterns. And if you compare all these keywords from the keywords of other countries, you can kind of build an estimate on what's the impact of government responses. For example, the Singapore government announced phase 3 with some terms, and probably some other countries have done this before. So then you have some estimate on what happens to the other countries when they relax some condition like number of people gathering or like overseas travels or something. So then you will know this beforehand by learning all this data from other countries. So then you also have some climate data. So probably not directly relevant to COVID, but you can use all these. But then you can also use this for some other projects. A lot of this data are in US, but some of these data are also available worldwide from the international worldwide weather stations on the world. Okay, so then what's really the next step? So once we are equipped with all these data sources, with all these tools, how can we use all these tools to build a public index or at least a corporate level index that we can use to improve our monitoring of all this data? So the first way is really internal. So once I build a product, I want to see the result of my product in real time. So I don't want to wait for the quarterly reports from my account managers. I want to build a dashboard that can monitor all this data in real time and react very quickly to the customer feedback. Also, it may not be you may not have to use all this data directly on your product. Maybe you only want to use the public data to assess your internal data. For example, I know for example, the public data will tell me what's my incidence rate for COVID or for some other conditions. But the public data will not tell you what's the treatment cost of all these diseases. So you combine these two to get an estimate. I mean, how should I price the product based on external data of number of cases and internal data of treatment costs. Of course, externally, you want to build some dashboards to encourage cross-team sharing. So then all the data is black and white there. So there is no confusion on what's the performance of my product and my marketing or something. And also this helps you to work with startups. So the startups will be working on a very fancy technologies that are cloud-driven, so that you may not have direct access to, but the startups should be providing you a dashboard on the performance of whatever data they're working with. So then you're embedded, you're in a good situation to have some control and management of the product. So you don't leave your product to the startups, and you actively get involved in the management of all these products. And the other benefit is that all these dashboards, they provide you better integrations. So for example, the Singapore government provides an API for the traffic data. But actually, for all these dashboards, you can embed it, you can provide you a URL. So it's a website. So you click this website, you will see the data. So then it's kind of convenient that everybody have access to the data. And also, one more use case is really China's use case of the 相互保. So it's like a Chinese Alipay's mutual insurance. So they publish the number of cases online for the people to view. Then people have trust in the program that the insurance company is not overcharging the customers. So in more than 1 year's time, they've achieved 100 million customers. So say this is some amazing job done by sharing data publicly with your customers to build a trust between the customers and insurers. And also for our COVID-19 working group, we are working on a few tracks. So then we are using this data to understand, what kind of insurance products and what are inclusions and exclusions over pandemics, and trying to figure out what's the lacking coverage and reasons. So if you combine that with the kind of symptom search data, then you will see what kind of coverage the customers are looking for and try to improve on that. So then we are trying to get some data from MOH. So then link that with the pattern of the outbreak and government policies. So to help the insurers to better price such products. For example, now we see COVID products for travelers. If you travel from overseas, you can buy a COVID product from, I think, AIG, Hongliang, and some other insurers. Also, we are really trying to improve the way that the insurers can react to future pandemics and to support the public interest. So with the experience from COVID, if the insurers know the way to build some dashboards themselves, that is more specific for more I would say more insurer specific, then probably will help the insurers to develop better products within a shorter time period. And also, we also have an initiative on the climate index. So in many countries, there was an actual climate index done, I think, probably in US, Australia, New Zealand, but nothing is really done in this region yet. So we are looking forward to building some climate index that is public and everyone can view. So for example, we know that I think NTUC has launched something with Grab. So if you're caught in the rain, then there will be you can make a claim on your Grab rides. But if you have this weather data available online, then you don't really need the customer to submit a claim. So the claim can be paid directly to customers by reading the weather data from the Singapore government or weather NEA. Then a lot of countries are offering kind of agricultural insurance, crop insurance to their farmers. So if there was a public climate index that tracks the rainfall temperature, then we can kind of use a proxy to provide insurance coverage. Because still weather is the most significant factor to impact the crop growth. And also, there's also some very interesting work done on sea level rise. For example, I mean, these are two examples. So this is New York, Manhattan. So this gives you an example that if the global warming, the global temperature, average temperature raised by 2 degrees, which areas of New York will be flooded? So then if you work on some property insurance or something, then you will have some idea that if the sea level really increased that much in, I don't know how many years, then which areas will be flooded? And probably make a claim from you. Okay, so thank you for your time. So that's all for my presentation. And if we still have some more time, I can share something else with you. So let me share this with you. So previously I shared a static version of this dashboard with you, but actually you can also, I can also show some more dynamic version. You move your mouse along this line, then you can see number of cases every day. Then if you click some countries, then the whole dashboard will refresh to only show that country. And if you choose a different time periods, then this will refresh automatically. And you'll see the latest data we get is November 29th, November 25th. November 25th. So then this dashboard really refresh automatically. So you don't need to spend any resource to maintain this. And the best part is this dashboard is done in a URL. So if you provide this link to anyone, then anyone can view this data. So this is really a public index. Okay, so that's all for my presentation. Thank you for your time. Hope we can work together to build some published dashboards and improve this industry together.
Thank you, Jack.
Yeah.
We are 3 minutes over time, so and I don't have any question that popped up in the system, so yeah. Maybe we can end the session for today. Thank you, Jack.